Over a century ago, rails like these became the steel bands that bound this land of ours together, enabling it to emerge as a great and powerful nation. Today, in the most overall fuel-efficient transportation method known, American railroads serve 45,000 communities with 1.7 million freight cars. The railroad industry and our nation have entered a new era. One of the dictates of that era is for many thousands of miles of new rail to replace the old. The requirement is for new rail to meet the stringent demands of today's heavy load, high-speed railroading, for production technology that results in a world-class rail.
Here in Monessen, Pennsylvania, in an area that saw the beginning of the steel industry in North America, Wheeling-Pittsburgh has added a new page to the history books. We have built from the ground up the first all-new rail-making facility in the United States since 1921. This mill bears the distinction of being the first universal rail and structural rolling mill in North America. The combination of our new continuous boom caster and rail mill cost us over $165 million, but it gives us the state-of-the-art in rail mills worldwide. It enables Wheeling-Pittsburgh to provide the American railroad industry with the rail of tomorrow to meet the requirement of the high speed and the 100-ton freight cars of today. With the knowledge that America's railroad systems have a critical need for rails to modernize and replace trackage, we've taken the most advanced, proven technology from all over the world and combined them in a mill that is producing daily for our customers the highest quality rail, unexcelled in the world.
Wheeling-Pittsburgh Steel produces just that, world-class rail. It begins its life in the heart of our modern basic oxygen furnace. The furnace is first charged with molten iron from the blast furnace. Then, from the oxygen lance that probes deep into the fiery liquid, oxygen is injected at a speed faster than sound. Inducing oxygen in this manner speeds the oxidation process, saving time and allowing for accurate control of the properties of the liquid steel as it evolves out of the molten iron. But this is only the beginning of Wheeling-Pittsburgh's state-of-the-art technology in modern rail production. In the foreground are blooms from which our rails are made, the outstanding product of our continuous 5-strand boom caster, seen in the background. As with our new rail mill, we have taken proven world community technologies and combined them into a totally computerized process. Continuous bloom casting means that the pouring of liquid steel never stops. When one ladle is empty, it's swung out of position over the tundish. Ceramic tube, called the shroud, is cleaned out and made ready to attach to a full ladle of molten steel. The liquid steel pours through the shroud into the tundish, where it's metered into 5 mold openings where it's tripped downward through the caster. As the steel moves slowly downward, the blooms take shape, an internally superior and homogeneous steel. They are continuously sprayed with controlled water volume for precise cooling as they move through this shrouded section of the caster. Finally, the blooms emerge in their curved molds and travel to the bottom, where they are met by the automatic cutting torches. The torches move along with each strand, cutting it to an exact length. This unique caster is totally computer controlled and equipped with the most advanced automation and engineering techniques to improve quality and lower cost. From this point, blooms are sent to the reheat furnace at the head end of our new rail mill. This bloom from our continuous caster is about to start its journey through the world's first totally computer-controlled precision rail rolling and straightening line. By the time it reaches the end of the rail mill, this 15-foot-long bloom will have become 4 39-foot or 2 78-foot lengths of the finest, most modern rail ever produced. The bloom is first charged into this 3-zone reheating furnace, where it will be brought up to a temperature required for hot rolling. At the exit end of the furnace, blooms emerge into the rail mill at a steady production rate, while others are being charged into the furnace behind them. Only capability like this can make Wheeling Pittsburgh's rail production capacity possible, up to 400,000 tons per year. The bloom is removed to a roller line and sent through a descaler to eliminate furnace-induced scale buildup and assure a maximum quality finish. As the bloom moves through the mill, quickly changing shape, every step of its progress will be watched constantly by the unblinking eye of the television camera, which sends its images back to the control pulpit. Now our bloom heads into the #1 breakdown mill. This is a 36-inch, 6,000 horsepower, 2-high reversing mill. In it, the bloom, in 9 working passes, is roughly formed into the basic rail profile. Each squeeze of the mill and each pass is gentle enough so that no splits or seams occur. Through it all, the roller operator in #1 control pulpit physically manipulates the bloom and keeps a watchful eye on the monitor screen. Each pass through the mill is under direct control of the computer using preset programming. Before leaving #1 breakdown mill, the roughly shaped rail is turned on its side. It will remain in this position without turning for the rest of its travel through the hot rolling line. This eliminates the danger of twist fatigue. Now, control of the rolling operation is handed off to #2 control pulpit, where the operator monitors the computer-controlled operation. Always the watchful TVI reports back. And the rough rail enters #2 breakdown mill. As it goes throughout every operation, the rail is descaled to maintain optimum surface quality. Another powerful 2-high reversing mill, #2 effects 3 passes on our shape. shape continues to reduce in size. Always the computer dictates perfection. As the last pass is completed in the number 2 breakdown mill, the more refined shape is ready for the universal roughing and universal edging mills. There are 5 working passes through the rougher and unique shifting edger mills, each totally under computer control. For each pass, continuous input feeds into the computer's memory bank. In real time, the computer checks the input against precise specifications and makes instantaneous adjustments when needed. Roll design ensures section uniformity throughout a rail length. As rolls wear, the computer, which monitors constantly, effects minute adjustments to the rolls to compensate for wear. The result is a critically precise match to rail specifications. And it's off to the universal finishing mill for one final pass. Here, the computer may make minute adjustments to maintain the remarkable symmetry of the rail, achieved by dressing all sides of the rail simultaneously in a controlled manner. The base roll, in addition to maintaining tolerances, also brands the rail. When the rail emerges from the universal finishing mill, still in excess of 1500 degrees Fahrenheit, it is to the exact specification ordered by the customer. At this point, the rail travels through the automatically indexed stamper, which stamps into the web without any damage the rail code, identification letters, and numbers. This rail is now over 165 feet long as it moves to the hot saw for end cropping. It is at the hot saw where samples are taken for a variety of quality control checks on dimensions, symmetry, surface, internal structure, hardness, and ductility. Then the rail is cut into 2 lengths, each over 80 feet long, and moved to this sophisticated cooling bed for precise cooling to meet mechanical requirements. Walking beams, fully adjustable for speed and stroke, ensure that rails are never exposed to mechanical damage. On the cooling bed, the rail is finally turned onto its base. When it is cooled to a point where it can be picked up safely between 725 and 1,000 degrees Fahrenheit, it's moved into the cooling boxes. The cooling boxes have been designed to meet American Railway Engineering Association specifications and will contain the rail for controlled cooling to 300 degrees Fahrenheit or less. This takes a minimum of 10 hours, but typically rails remain in the boxes for 15 to 20 hours. Controlled cooling has proved to be a successful method for eliminating hydrogen. This two-plane mechanical roller straightener was tailor-made for Wheeling Pittsburgh's rail mill. The only one of its kind, it's a triumph of modern engineering. It's capable of straightening rail of up to 155,000 psi yield strength in one single pass. Using the triangulation concept in working all planes of the rail simultaneously, all straightening problems are completely eliminated. And then, for initial finishing line inspection of the product. First, it's a visual check for overall straightness and surface quality. The rail is marked for cut. The most definitive inspection to verify internal integrity is done electronically by the inline multiple probe ultrasonic tester, which examines the rail as it goes by. Suspect areas are marked automatically and then re-inspected with a hand probe. The rail, now nearing the end of the mill, moves to the cutoff saws, where it will be end cropped, drilled, if that is specified, and finally cut to either 39 or 78-foot lengths. Final inspection is a combination of automated and computer-controlled processes with final sign-off by highly trained quality control inspectors. And so you have seen Wheeling Pittsburgh Steel's answer to the challenge of the new era for America and American railroads. From the ground up, a brand new $165 million continuous caster and rail rolling mill, producing on a daily basis the finest rail in the world.
To sum up what you have just seen, it is safe to say that the combination of Wheeling Pittsburgh's computerized continuous bloom caster and rail mill is a combination unique in the world today and the best in the world today. Every foot of our rail is made from high-quality booms produced on our new continuous caster. In the metallurgy and character of the steel and the dimensional accuracy of the rail, our product is unexcelled. We are proud to be able to serve the nation's railroads now and in the future with what is truly world-class rail. This is one of the many giant strides we have taken in Wheeling-Pittsburgh to become the highest quality, lowest cost steel producer in this country. We believe our customers require steel produced on modern steel mill equipment with the best available technologies.